Today I'm going to go over solving linear inequalities. So here are some definitions. A linear inequality is an equation with an inequality sign. So instead of an equal sign, I'll have one of these. Less than, greater than, less than or equal to, or greater than or equal to. A compound inequality is an inequality that consists of two simple inequalities joined by and or, and it'll always be one of these two words. An equivalent inequality is inequalities that have the same solution as the original inequality. So here are the steps to solving linear inequalities. First, you'll want to distribute and combine like terms, move the variable to one side and constants to the other, and then you have to solve for x. So for and inequalities, they'll look something like this. So this means x plus 2 is less than 7 and greater than negative 5. So for those, you want to try to isolate the x in the middle. So you would want to get this by itself. And if you have to multiply or divide by a negative to get x by itself, then you have to flip the sign. So if it was a less than sign, then you have to flip to a greater than. And then you'll have to graph. So if it doesn't have an equal to, then it's going to be an open circle, and if it does have an equal to, it's going to be a closed circle. If you write your answer with x on the left, if it's less than, then you'll be shading to the left, and if it's greater than, you'll be shading to the right. So let's start with some examples. So let's say we have 20 minus 2x is greater than negative 2 times x plus 2 plus 4x. So our first step is to distribute the negative 2. So we get 20 minus 2x is greater than negative 2x minus 4 plus 4x. And then we'll want to combine like terms. So on the left-hand side, there's nothing we can combine. And on the right, we can combine negative 2 and 4. So that's going to be 2x. So 20 minus 2x is greater than 2x minus 4. I personally like moving all the variables to the left, so I'm going to move the 2x over. So then we get 20 is greater than, 20 minus 4x is greater than negative 4. And then we'll want to move the 20 over, so subtract 20. Negative 4x is greater than negative 24. And then divide by negative 4. So then we get x is less than, since we divided by a negative, we have to flip the sign. So x is less than 6. So on our number line, we can place 6 anywhere, but I'm just going to place it in the middle. And then since its x is less than 6, it's a open circle since it's not equal to. Hold on, I'm going to try to draw that better. So open circle at 6. And then we're going to be shading to the left since it's less than. So you can shade, or I like just drawing a line on top. So this is how I usually do it. But you can also shade the number line. So here's one way, or you can also just shade this in. Either way is fine. Okay, so the next example, we have 36 is less than or equal to 11 plus 5x is less than or equal to 66. So this is an and inequality, and we're trying to isolate x in the middle here. So to get that by itself, we have to subtract 11x on all sides first. So then we get 25 is less than or equal to 5x is less than or equal to 55. Then to get the x by itself, we have to divide by 5. So then we get 5 is less than or equal to x is less than or equal to 11. So now on my number line, I want to make sure I have 5 and 11 on my number line. So I'm going to start with 4. Okay, so now we have x is basically between 5 and 11, and since it's equal to, that means it's going to be a closed circle at 5 and at 11. So at 5 I'm going to have a circle here, and 11 I'm also going to have a circle. Okay, and then I'm just going to fill it in. So color it in. And if you shade, you would just shade in between like this. But I like drawing a line in between them. Either way is fine. Oh, that was really ugly. Okay, I fixed it. Okay, so there's the second example. So here are the first two examples. Okay, the next one we have an OR inequality. So this says 2x minus 3 is less than 11, or negative 8x minus 10 is less than negative 82. So for OR inequalities, you're just going to solve each one individually and then keep the word OR in the middle. So for the left one, to solve, we're going to add 3 to both sides, and we get 2x is less than 14. And then we're going to divide by 2, and we get x is less than 7. And then on the right hand side, we're going to add 10 to both sides. Then negative 8x is less than negative 72. And then to get x by itself, we're going to divide by negative 8. And since we're dividing by a negative, we have to switch this to a greater than instead of a less than sign. So greater than 9. So our final answer would be x is less than 7 or x is greater than 9. So on our number line, we need to have the numbers 7 and 9. So I'm going to start at 6. Okay, and we're going to have open circles because neither of them are equal to. But they could be different, like one of them could be equal to. So x is less than 7, that means we're going to shade to the left. And x is greater than 9, that means we're going to shade to the right. So for the next example, we have 14x plus 20 is less than 2 times 6x plus 8, or 8 minus 10x is less than or equal to 3 times 5 minus 3x. So again, since this is an OR problem, we're going to solve each one individually. So on the left-hand side, we first want to distribute. So we get 14x plus 20 is less than 12x plus 16. And then we can't combine any like terms, so now we want to move all of the x's to one side. So then we get 2x plus 20 is less than 16. Subtract 20. We get 2x is less than negative 4. Divide by 2. And x is less than negative 2. And then for the right hand side, we're going to distribute 3. So 8 minus 10x is less than or equal to 15 minus 9x. And then again, move everything to one side. So we get 8 minus x is less than or equal to 15. And then we're going to subtract 8. So we get negative x is less than or equal to 7. And then divide both sides by negative 1 to get x by itself. So x is greater than or equal to -7. So we have x is less than -2 or x is greater than or equal to -7. So on our graph, that means when we graph, we're going to have an open circle at -2, and we would be shading this to the left since x is less than. And then for x is greater than or equal to -7, that means that -7 will have a solid point. And since it's greater than or equal to, we're going to go to the right. So since this is an OR problem, OR means anywhere that is shaded on your graph. So if you chose to shade instead, you would shade this way for -2. Oh, my line kind of got crooked. Okay, for -2. And then for x is greater than or equal to 7, you would shade the other way. So that means the entire number line is shaded. So for this problem, the answer is all real numbers. And your entire number line should be shaded. So let me just try to erase some of these lines. So what I usually do for a graph that is all real numbers, I just draw another straight line on top. But again, if you shade, you would just shade in the entire number line. You would just shade all of this in. Thank you so much for watching. Let me know if you have any questions. Just leave a comment down below and I'll try to get back to you as soon as I can. Bye!